5.1c is about negative and zero exponent rules. So these are just two more rules that we're going to talk about. Here are the rules we've talked about so far: the product of a power, quotient of a power, and power to a power rule. Today we're looking at the zero and negative exponent rules, so let's take a look at why they work. All right, so in order to do that, we're going to look at these two tables. So we have 2 to the 5th equals 32, 2 to the 4th equals 16, 2 to the 3rd equals 8, so on and so forth. All right, so we're going to fill out the rest of this table. So basically, as the table is going down, right, 2 to the 5th, 2 to the 4th, 2 to the 3rd, each time we are multiplying by 1 less 2, right? So each time our exponent is decreasing by 1, which is the same as saying that each time we are dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So now we know that 2 to the 0 power equals 1. Right? And that's why this works. This descending chart, that's where our zero and negative rules come from. Let's keep going. So 1 divided by 2 is half, or 1 over 2 to the first power. 1/2 divided by 2 is 1/4. Or we could write 1/4 as 1 over 2 to the second, right? Because 2 to the second, or 2 squared, is the same as 4. If we divide by 1 more 2, well, 1/4 divided by 2 is 1/8. Or, okay, if we're dividing by 1 more 2, we had 2 to the first power here, 2 to the second power here. So this would be 1 over 2 to the third power. Okay? So if you have a negative exponent and you want to make it positive, basically you put it on the other side of your fraction. If we look at our base of 10, so 10 to the 5th, so on and so forth, we see the same thing, right? Each time we're dividing by 10, 100 divided by 10 is 10. 10 divided by 10 is 1. So we see 10 to the 0 power equals 1. 1 divided by 10 is 1/10. Well, 1/10 divided by 10 is 1/100th, which we could write as 1 over 10 to the second power. So this is why our zero and negative exponent rules work. This is where they come from. So in general, anytime you have something raised to the 0 power, it equals 1. Anytime, every single time. That's the easiest exponent rule there is. Then we have the negative exponent rule. So if we have x to the negative m, that's the same as having 1 over x to the positive m. Also, or vice versa, if we have 1 over x to the negative m, that's equal to x to the m power. Okay, so basically if it's negative, you just put it on the opposite side of your fraction, and that makes it positive. Let's practice using these rules a little. We have k to the negative 4th. Well, we just said that if we put this on the opposite side of the fraction, it'll become positive. So since k to the negative 4th is in the numerator, if we put it in the denominator, it's positive. So k to the negative 4th is equal to 1 over k to the 4th. Over here, well, we have our negative in our denominator, so we would flip that and we'd have y to the positive 6 over 1, which we could just write as y to the positive 6. So again, all we're doing is putting that negative on the opposite side of our fraction. We have negative 5 times m to the negative 3rd power times n to the 9th power. All right, so we just have a couple more terms here. Well, negative 5, that's just a whole number, so we're not going to do anything to change that. M to the negative 3rd power, we have to put that in the opposite half of our fraction, and then n to the 9th power gets to stay in the numerator. So that's our answer, okay? If we're looking at letter D, right, we've got a whole bunch going on inside our parentheses, but all of this is raised to the 0 power. And remember, anything raised to the 0 power equals 1. So our answer is just 1. All right, so remember, our goal for these is to simplify them, and we want all of the exponents to be positive in our final answer. So letter E, we have f to the 5th power times f to the negative 8th power. We could do different things. It doesn't matter what order you do them in, just your personal preference is going to come into play, okay? You could use your product of a power rule, So since we are multiplying, we know that we want to add these exponents. Well, 5 plus -8 is -3. And then we would have 1 over f to the third power. So we could solve it like that. If you wanted, you could look at it and say, well, f to the fifth power is positive, so that's going to be in the numerator. F to the -8 is negative, so that's going to be in the denominator. And then when we simplify that, again, we're going to get 1 over f to the third power. So it didn't matter which way we did it. Okay, it didn't matter if we used our product of a power rule or our quotient of a power rule. We ended up at the same place. So there is going to be a couple different strategies or methods that you can do for these more complicated exponent problems. Looking at letter F, well, our terms are kind of mixed up, so I'm going to organize them. I have a squared times a to the sixth times b to the -3rd times b to the third. Well, my a is 2 plus 6 tells me I have 8. And then b, I'm going to put it in a fraction, so I have b to the third over b to the third. Well, hey, those cancel each other out. So we get a to the 8th. Keeping on here, letter G. If we have -2 times v squared raised to the third power, 3 times v raised to the 0 power, times 4 times v to the -9 power. Okay, so a lot of little different parts, so you just have to take it one step at a time. Well, -2 raised to the third power, v squared raised to the third power, we'd multiply those so we get v to the 6th. Anything raised to the 0 power is still 1, so we can just kind of cancel that out. That 1's not going to change anything, right? Multiplying by 1 doesn't do anything. Then we have 4 times v to the -9th. Okay. But since it's negative, we can go ahead and we can put that in our denominator to make it v to the +9th. All right, well, -2 times -2 times -2 is -8. Then we've still got 4 times 1 times v to the 6th. So again, I just reordered all of my terms. Okay, well, -8 times 4 times 1 is just -32. And my v's are going to simplify down to v to the third. So -32 divided by v cubed is our final answer. Okay. So be a good time to pause and maybe try letter H for yourself. Again, a couple different methods you could do. You could simplify them first, or you could get your negative exponents in the correct place first. It doesn't really matter. It's just your personal preference. So I'm going to put them on the right half of the fraction first. Okay, so my m to the 4th is going to come to my denominator. M squared stays in my denominator. N to the -8th is going to come to my numerator. N to the -12th needs to go in my denominator. P to the 7th is going to stay in the numerator, and P is going to stay in the denominator. So now I can simplify. Well, I'm going to have P to the 6th divided by M to the 6th times N to the 4th, and that's my final answer. Again, a lot of different methods you could have used to solve that one, just your personal preference. Here we have 3/4 to the -2nd, so we could distribute that negative to each one and get 3 to the -2nd over 4 to the -2nd, and then basically just flip our fraction upside down. Right? We'd have 4 to the 2nd over 3 to the 2nd. The other thing we could do is just flip it right away. So we could say, well, if we have 4/3 to the +2, that's still going to be 4 to the 2nd over 3 to the 2nd. So either way, you are going to end up with 16 over 9 as your final answer. The sad 9. All right. Letter J, same type of thing when we have it raised to that -3rd power. I'm just going to flip right away. So I'm going to put what's in my denominator on top and then my numerator on the bottom. Then it's raised to the +3. Remember, power to a power, we're going to multiply our exponents. So p to the -3rd times, raised to the 3rd power will be -3 times 3, which is -9. 4 to the 1st power raised to the 3rd power leaves us with 4 to the 3rd power. m to the 8th power, well, 8 times 3 is 24, and then n to the 4th power, 4 times 3 is 12. One last step, right, because we have a negative 9 in our numerator, so we need 1 over 4 to the 3rd times m to the 24th times n to the 12th times p to the 9th power, and that is our final answer. Okay, I'm going to make one little change. We can actually evaluate 4 to the 3rd power. 4 times 4 is 16, and 16 times 4 is 64. So that's how we should write our final answer. Just to review, if it's a negative exponent, basically put it on the opposite side of your fraction. Anything to the 0 power is going to be 1. Remember to answer the questions in your quiz and hit submit.